example 4 for the limit of a function, our last example. I wanted to go over this one because it's a case that comes up pretty often. And we have to find the limit as x approaches 2 of f of x, and f of x is defined by this graph here. Okay, so we have a line with a hole at 2 at a y value of 5, but for a x value of 2 it's defined at 8. Okay, so it's a piecewise function. So sometimes you'll be given a graph like this, sometimes you'll be given a piecewise function like we were given in example 3, and you'll graph this. And they're asking what's the limit as x approaches 2 of this function. Well, to find the limit we got to find first the one-sided limit. So what's the limit as x approaches 2 from the negative side, or from the left side of f of x? Well, as x is approaching 2, the y value is approaching 5. So it's equal to 5. The limit as x approaches 2 from the positive side, so as x is approaching 2 from the positive side, the y value of f of x is also approaching 5. And therefore, the limit as x approaches 2 of f of x, the general limit, since it's approaching the same value from both sides, it's also equal to 5. A lot of people sometimes think that the limit doesn't exist because the function is defined at 8, but it doesn't matter where the function is actually defined. All that matters is what is the function approaching as we approach our respective x value. And it's approaching, the y value of this function is approaching 5 as x approaches 2, so the limit as x approaches 2 of f of x is equal to 5.